Hello everyone, I hope you all are good and you all are practicing problems. Let us for now get at this one. So what is question? The earth is a homogeneous sphere of mass m and radius r. Homogeneous meaning its mass is uniformly distributed inside the volume, that is its density is constant. So it is like this. This is earth. It has radius of r, mass of m. And then there is another planet of the same radius and of the same mass, but the problem here is, or difference here is, density is not uniform, it's not constant, rather it is changing, and it is changing as a function of radial vector r. So rho equal to some constant rho naught into r. Done it? And in both these cases, in for first option, what we have to check? We have to check electric field, sorry, gravitational field on the surface of Earth and gravitational field on the surface of this planet. And then we have to take the ratio. So let's say here it is GE and here it is GP. So we have to talk about GE by GP. What will be the value? ठीक है. सो देखो, सबसे पहले हम अर्थ की अगर बात करें, सो दिस इज सेम लाइक वी आर टॉकिंग अबाउट अ सॉलिड स्फीयर which has certain mass m, its radius is r, and mass is uniformly distributed. So we are talking about uniform solid sphere, and in that case we have already read the formula. You must have done the derivation part also. Gravitational field on the surface will be equal to how much? It is equal to gm by r का square. ठीक है. So for earth if you write, this will be the case. Done है. And the same formula directly we cannot translate to that planet thing because mass is not uniformly distributed. As we will move away radially outward, mass is getting more concentrated, right? Because density is bigger as we are moving away from the center. So center के पास वाले region lighter है, center के दूर वाले region they are more heavier, right? So mass is not uniformly distributed. How we can calculate gravitational field over here? सो देखो, एक तो तरीका ये है कि आप इंटीग्रेशन करो. वी कैन डू दैट, वी कैन इजिली कैलकुलेट द वैल्यू. एंड अनदर थिंग इज बाय यूजिंग प्रॉपर डाइसेक्शन. जैसे इस क्वेश्चन को प्रॉपरली आप देखने की कोशिश करो. जैसे आपने सॉलिड स्फीयर के डेरिवेशन में पढ़ा होगा, फॉर ए पॉइंट ऑन द सर्फेस एंड फॉर अ पॉइंट आउटसाइड द सर्फेस, दिस सॉलिड स्फीयर बिहेव्स लाइक, when you're calculating gravitational field, this solid sphere behaves like its mass is concentrated at the center. I mean, calculation of gravitational field, it feels like mass is at the center. ऐसे तो mass concentrated है at the center, because if this is uniform sphere, in that case its center of mass and geometrical center will coincide, right? They're going to coincide. So actually this is the center of mass position. And for the calculation of gravitational field for any outside point and for a point on the surface, we simply get the formula like gm by r ka square. So it feels like mass is at the center and point is at a distance r from it. So it behaves like a point mass which is at the center. Can we use the similar discussion over here in the case of planet? तो देखो, हम use कर सकते हैं to the long center of mass of this solid sphere is coinciding with its geometrical center. अगर कर रहा है तो आप directly use कर सकते हो. जैसे यहाँ पे आप ध्यान से देखो, what will be the thing? Mass is what? Mass is uniformly changing, right? It is, sorry, density is changing. So density is rho naught r. अब आप ध्यान से देखो, अगर मैंने कोई भी एक आर रेडियस का होलो स्फीयर लिया, इस होलो स्फीयर का सेंटर कहाँ होगा? Center of mass I'm talking about. This hollow sphere is geometrically centered at this point O. Where will be its center of mass? So आप ये कहोगे कि इस hollow sphere का जो हर point है, this is at a distance r from the center. So at each point density is same, right? For this hollow sphere. And in that case, you can always say for this portion and for this portion, center of mass will be this center O. Okay? For this portion, center of mass will be O. So overall, center of mass of this sphere is going to be what? It is going to be O. And अगर आप कोई भी, जैसे इसको थोड़ा मैं बड़ा बनाती हूँ, ये स्फीयर ले लो, हॉलो स्फीयर, ये ले लो, ये ले लो. सारे होलोस्फीयर का सेंटर ऑफ मास कहाँ होगा? ज्योमेट्रिकल सेंटर पे होगा. सो ओवरऑल दिस होल सॉलिड स्फीयर is getting formed by such so many holospheres whose radius is changing from 0 to capital R, right? So overall आप कह सकते हो कि ये solid sphere का center of mass कहाँ होगा? At its geometrical center. And if this is the case, then for a point on the surface and for a point outside the surface, you can treat that whole mass is over here and then you can calculate gravitational field. So for the surface अगर मैं निकालूं तो मैं क्या लिखूंगी? gm by r का square. So we are getting the same value, right? So this is also gm by r square, this is also gm by r square, and thus we will get 1. ठीक है. I will show you through integration also how this gp will be gm by r square, but before that let us calculate this rho naught. What is this rho naught? Done hai? We are given mass of planet m. If we try to calculate mass of planet in terms of density, then we can get the value of rho naught. एक काम करो, I mean how we select element. We basically need to deal with the element selection. अब देखो इसका mass कहाँ distributed है? Mass is distributed in the volume. So you need to pick an element which will have a volume. So let us take one hollow sphere at a distance r, and this hollow sphere has a thickness of how much? This has a thickness of dr. ठीक है. So this hollow sphere, this element will have small volume and that will be equal to 4 pi r square into dr. Now what will be the mass of this small element? That will be equal to rho into this much, and rho is rho naught r into 4 pi r square dr. So this will become how much? 4 pi rho naught r cube dr. This is a small mass. And if we have to calculate the total mass, we need to integrate this. So आप इसको integrate कर लो. If you integrate it, how much value you are going to get? R cube dr, 0 से r तक limit will vary, right? So m is equal to 4 pi rho naught को आप बाहर लो, r cube dr, r4 by 4. So that will become r4 by 4. This will get cancelled, and rho naught is equal to how much? Rho naught is equal to m by pi r ka 4. So this is the value of rho naught you are getting. And if you want to calculate gravitational field on the surface of planet by using integration method, again element selection you need to do. And as we are saying that this solid sphere is made of so many hollow spheres starting from radius 0 to capital R, again element we will be taking a hollow sphere as an element. So let us take hollow sphere of radius r whose thickness is how much? Dr. Now because of this, what will be gravitational field over here because of this element? So let us say this element has a mass of dm. So g dm by this distance ka square, this distance is r, so r ka square. This will be the small gravitational field, right? Why this? क्योंकि आपको पता है अगर hollow sphere है जिसका mass dm है, then for any outside point, at a distance r, gravitational field will be equal to how much? G mass of hollow sphere divided by distance ka square. Same thing I have done here. So now in order to calculate this whole G, you will be integrating it. Now integrating means what? You will be adding all the small gravitational field values. But field is not a scalar quantity, this is a vector. We need to add it carefully. So we need to check before doing the integration that all value of gravitational field because of all the elements will be in same direction or different. Agar same direction mein hai, we can add it scalarly. If they are oppositely or differently oriented, we cannot add it simply scalarly like this. ठीक है. सो आप चेक कर लो ग्रेविटेशनल फील्ड का डायरेक्शन क्या होता है. ग्रेविटेशनल फील्ड मीन्स फील्ड बिकॉज ऑफ मास दैट इज एन अट्रैक्टिव फील्ड दैट विल बी ऑलवेज डायरेक्टेड टुवर्ड्स द बॉडी. ठीक है. हियर इन दिस केस वी कैन से इट विल बी डायरेक्टेड टुवर्ड्स द सेंटर. यू मस्ट हैव स्टडीड दिस थिंग, राइट? सो no matter you are taking a sphere of what radius, gravitational field will be in this direction. So for all spheres that you are going to take as an element will have a gravitational field directed towards the center. So their direction is same. We can simply add it scalarly. Let us add it now. G into dm. dm का वैल्यू आप क्या लिखने वाले हो? यहाँ से आप देख लो, सॉरी हमने यहाँ पे लिखा था ना. सो dm was equal to how much? 4 pi rho naught r cube dr. सो यहाँ पे आप लिखो 4 pi rho naught r cube dr, and then there is this r square का term integrated. ठीक है, 0 से r. So this is equal to how much? 4 pi rho naught by r square into g into r4 by 4. This is what we are going to get the value of g on the surface of planet. So इसको आप m के term में लिखने की कोशिश करो. M is equal to how much? Right now we have seen rho naught into pi r4 is equal to m. So आप यहाँ से लिखो 4 को पहले तो आप कैंसिल कर दो. Rho naught into pi r4 will be mass. So this whole is going to be mass, pi rho naught into r4. So m and g is there and divided by r ka square. So we are getting the same value. You can also do it from the third method, that is flux method. Again, I don't know if you people know it or not. For class 11th students, maybe they are not aware of this, but class 12th वालों को तो पक्का पता होगा. And this is that gravitational field का flux through closed surface is equal to mass enclosed, and this is for them I am explaining, mass enclosed by 1 upon 4 pi g. This is the formula we can use. Now for a point on the surface, I mean at each point on the surface, gravitational field will be constant because you just now have seen that if you're taking any element, on that element, mass of each point will be what? Same. And from this thing, we can conclude that gravitational field at this point, at this point, at this point, at this point is going to be same. And similarly, we can say whatever is the gravitational field here will be here, will be here. So Eg will be constant and Eg dot ds, आप लोग देख सकते हो, area vector will be normal, outward normal to the surface. So flux will be negative here, but let me write just the magnitude. Eg summation of all ds equal to mass enclosed is m, because inside this point or inside this surface mass is what? Capital M divided by 4 pi g. So Eg into 4 pi r square equal to m by 4 pi g. So यहाँ से अगर आप लिखते हो तो ओके 1 upon 4 pi g था ना, देखो मैंने यहाँ पे गलती कर दी. This was how much? 1 upon 4 pi g, right? So this will become 1 upon 4 pi g. So this will get cancelled and Eg will be equal to how much? Gm by r square. For class 11th students, if you are not aware of this, you can comment in the video, I mean in the comment section. You can let me know that you want detailed thing on this one. Then I will go with this one, okay? Otherwise, this is here. I hope you have understood all the things in this question, but if you have doubt anywhere, you can always let me know in the comment section. Okay? Thank you. Take care of yourself. Bye-bye.